Here we have a question on forces. So we have a diagram of a roller coaster with 4 forces acting on it. And it wants 2 ways in which the force arrows show that they're vectors. Remember, a vector is a magnitude, which is the length, and direction. If you look at the arrows, they have different lengths. And different directions. And that's a key thing to remember about vectors. They have different magnitudes and directions. So which one shows the weight? Now you need to remember weight always acts straight down. So it has to be D. Weight always acts straight down no matter what. And show the normal contact force. This is the force that acts to the normal to the surface. Remember, just like in light, the normal is 90 degrees. So if you look at the surface, B is 90 degrees to the surface, so it must be B. Okay. Here we have a graph of magnitude of acceleration over the time since the ride starts. Why has a line graph been drawn instead of a bar graph? Well, line graphs are used if both values are continuous. That means numbers. So, both values are continuous. Bar charts are used if we have a continuous and a categoric variable. So like apples, bananas, dogs, those would be categories, single things. Whereas numbers would be continuous in most cases. So what conclusion can be made from figure 2 about the motion of the roller coaster train between 10 and 15 seconds? Okay, between 10 and 15 seconds. It's a straight line. So it is still, that's not one of the options, so it's constant velocity. Here the constant velocity would be 0 meters per second. What is the maximum acceleration of the roller coaster? Again, we choose our graph, our maximum here, and if we get a ruler and go across from that point, okay, that is 24.5. It's halfway between the 24 and the 25, what would be if I could draw a straight line. So that would be 24.5. The maximum safe acceleration for most people is 5 times gravity. That's gravity. Explain whether the acceleration is safe for most people. So we have to do 5 times 9.8, which will give us 49 meters per second squared. So, as 24.5 is less than 49, roller coaster is safe. So only when it exceeds that 49 does it become an issue. One of the passengers has a mass of 58 kilograms. Calculate the force. It gives you the equation. So we have mass. We have our acceleration from the previous question. We do F equals m times a, which equals 58 times 24.5, which gives us 1421. And then it wants units. So hopefully you'll remember that force is always measured in newtons.